Hi, this is Sung and I'm the Principal and Director of Sky Academy, and what we have done up until now is basically looked at the fundamental identity, which is sine squared plus cos squared equals to 1, and variations of that, and we've also looked at the reciprocal identities. Is that right? So now what we're going to be doing is basically questions that involve working through that understanding. Okay, so they're called trigonometric identities or trig identity questions. Okay, and some of them involve simplifying a specific trigonometric expression. Others of them require you to prove them. Okay, so let's have a look at the first one here. Sine squared plus cos squared equals to sine squared plus cos squared over tan squared theta. Now sine squared plus cos squared theta is going to be equal to 1, right? So sine squared plus cos squared theta is equal to 1 over tan squared theta, which is actually equal to cotangent theta. Cotangent squared theta. Does that make sense? And with these things, we often put the squared above the trig ratio, okay, rather than above the angle. Otherwise, it looks like we're squaring the angle before we multiply. We're squaring the angle before we're multiplying by the. Not multiplying by, but doing the trig ratio. Yep. So basically, by putting the square above the trig ratio, what we're saying is we're finding the ratio first and then multiplying by itself. Okay. So now the next one is cosec squared theta minus cotangent squared theta. Now, if we look at this particular identity, which is 1 plus cotangent squared theta equals to cosec theta, you will notice that cosec theta can be, or cotangent squared theta can be expressed as cosec squared theta minus 1, which is what we're going to substitute into here. So what we've got here then is cosec squared theta minus cosec squared theta minus 1, which gives us cosec and cosec will cancel out, and then you've got minus becomes plus, so these two will cancel out and we're left with 1, and that's basically what this expression is going to be equal to. The next one, sine squared theta over 1 minus sine squared theta. Now, what is 1 minus sine squared theta going to be equal to? Well, we know that sine squared theta plus cos squared theta is equal to 1. We bring the sine squared theta over to the other side and we get cos squared theta, which is equal to 1 minus sine squared theta. So 1 minus sine squared theta is equal to cos squared theta. We can replace 1 minus sine squared theta with that. Yep. So it's going to be equal to sine squared theta on cos squared theta. And we know that sine over cos, or we may not know this, but what we need to know is that sine over cos is equal to tan squared theta, right? And the reason why that is because tan is equal to y over x, which is equal to sine over cos. Alright, back over here. Yep. So sine squared theta over cos squared theta is equal to tan squared theta. Got that? So far, things are moving pretty well. Okay? Now we come to this particular question here, and we've got sine squared of 180 plus theta. Alright? So 180 plus theta is this over here, is minus sine. So what we've got is, let's work down here, 1 minus sine theta all squared. Does that make sense? Because 180 plus theta will give you minus sine theta, and we're squaring that. Okay? You square a minus sine theta, and that gives you 1 minus sine squared theta. Because you square a negative, it becomes positive. 1 minus sine squared theta which over here we worked out before, bring the sine squared theta over to the other side, is equal to cosine squared theta. So all of this is going to be equal to cosine squared theta. Does that make sense? So that's how you do the sort of questions that require you to simplify trigonometric expressions. Now what we're going to be doing is doing the sort of questions that require trig identities to prove other trig identities, right? So with this one here, what we're going to do is basically start from the left-hand side and simplify like we did here until we get to the right-hand side, okay? So left-hand side is equal to sec theta plus tan theta. Now sec theta is 1 on cos, tan theta is sine on cos, which is just equal to 1 plus sine theta on cosine theta. Yes? Now, that's actually equal to the right-hand side. So I did a fairly easy one for the first one. So we moved from the left-hand side and we got the right-hand side. So that's the basic premise behind doing these sort of questions. I'll do the next one for you. It kind of looks a little bit more complicated. Alright, so you've got sine squared alpha cos squared beta minus cos squared alpha sine squared beta. And we've got to show that that's equal to sine squared alpha sine squared beta. So now what's in the way of us doing this? Well, we've got a cos squared beta that's in the way, and we've got a cos squared beta that's in the way here. Now what I would do is use our trig identity to basically make everything here a sine squared. I would do that. So basically, sine squared theta plus cos squared theta is equal to 1. Cos squared theta is going to be equal to 1 minus sine squared theta, right? So what we've got here is that the left-hand side is equal to sine squared alpha, which doesn't change, but we're going to replace the cos squared beta with 1 minus sine squared beta. We'll probably replace that. Let's replace it. So cos squared alpha becomes 1 minus sine squared alpha sine squared beta. Okay? So that's going to become sine squared alpha minus sine squared alpha sine squared beta minus 1 times sine squared beta is minus sine squared beta, minus minus becomes plus, plus sine squared alpha sine squared beta. Yes? Now what you'll notice here is this cancels with this because they're the same thing, and we're left with sine squared alpha minus sine squared beta, which is exactly what we wanted in the first place. Left hand side equals to right hand side, and that is how we prove trig identities. Okay, so I'll stand aside for the moment so that you can take that all in. But what I want you to do now is go away and practice a whole stack of them, just so that you become familiar with them. And when you do them, you will be needing to draw upon your fundamental identities, your reciprocal trig ratios, and the facts about the symmetrical properties of angles. Okay, so let me stand aside. Thank you very much for watching.